2.2 is about the first derivative. So what happened here is you have to know that first derivative means dy dx. Okay, dy dx. So like what I mentioned before, when you do differentiation to change y to dy dx, the dy dx is called first derivative. If you are given with function fx, you change it to f prime x, then we call f prime x as first derivative. So we have formula over here. So as you can see here, given y equal to ax to the power of n, you have the equation in y, and then you may also have equation in fx, okay, equal to ax to the power of n. So the formula to differentiate ax to the power of n is, you see the derivative, which is the formula, the dy dx is equal to nax to the power of n minus 1. Okay, or you can also write like this, f prime x equal to nax to the power of n minus 1. Okay, there are just two different ways to write down the first derivative. Either dy dx, as what I mentioned before, the differentiation of y will become dy dx. The differentiation of fx will become f prime of x. Okay, now how to understand this thing? Okay, so we have to think about it in this way. Okay, so let's focus on that now. We have ax to the power of n as the questions. When you do differentiation, the power n will go in front and become n that multiply with the ax, and the power just now become n minus 1. So basically there are two steps. The first step is the power go in front and multiply. The second step, the power minus 1, and that become the new power. So two steps. Okay, now let's see example. Okay, example, we have example over here, part A. Okay, so this is the questions. Y equal to 5x to the power of 4. So we write dy dx. Dy dx. So as the question said, differentiate each of the following functions with respect to x using the formula. Using this formula. Okay, so the power 4, that is the first step that I mentioned just now. The power 4, move in front and multiply. 4 multiplied with 5, we get 20. Then second step, the power 4, you have to minus 1 and it becomes power 3. So that are the two steps. Power bring in front and multiply, and then the power itself, you have to minus 1 to become power 3. Okay, so that is how we use the formula over here. So these are the formula. Okay, so sometimes your x stay at the denominator. So it is not always staying side by side with the numbers. So sometimes it stay at the denominator. Okay, so if that is the case, we have to bring it up. From the denominator, you bring it up, it becomes 3x to the power of negative 2. So of course, we learn this kind of techniques when we go through indices, where x squared you bring up become x to the power of minus 2. So we have to bring it up first so that it is of this form. A number x to the power of something. So as you can see here, a number x to the power of something. And now we can start applying the formula, and we will get the first derivative in this way. So imagine the minus 2 bring in front, multiply, minus 2 times 3 become minus 6. Then minus 1 to the power. So minus 2 minus 1 again, it becomes minus 3. Minus 3. Okay, so that are the two steps that I discussed with you just now. First step, the power bring in front and multiply. Second step, the power minus with 1 and then you get minus 3. Okay, so once you get this, right, we don't leave this as the final answer because our question itself is in fraction form. So let's change this back to a fraction form. What we do is we just bring this x with negative power to the denominator and it will become positive power minus 6 over x to the power of positive 3. So it's just the other way around. When we bring it up, it becomes negative power. Now when the negative power bring it down, it becomes positive power. So that is the same formula again. It is just that we need to bring up the x to the power of something, make it side by side with the number before we can start using the formula. Okay, so we already have 2 examples. Now let's look at the theory again. Okay, so you see we have a few ways to write down the first derivative. So when y is ax to the power n, we write dy dx equal to na x to the power n minus 1. This is the first way. The second way is if fx equal to ax to the power of n, then after differentiation it becomes f prime of x equal to na x to the power of n minus 1. And we have the third, sorry, this should be the second way, the second way to write down the differentiation. And the third way will be this way. This is the third way to write down the differentiation. Okay, so what happened here is differentiate ax to the power of n. You know, the question is straight away here. Differentiate, d over dx means differentiate ax to the power of n, and then same formula. The power n bring in front and multiply. Just now they write na, now they write an, same only. Okay, they are still multiplying, and then the power n become n minus 1. So the second step is minus 1 to the power. First step, bring the power in front and multiply. Second step, minus 1 to the power. So this is the third way to write down the first derivative. Okay, so now let's see example. We have C here, example C. Okay, d over dx, that means differentiate 8x. Okay, let's put it in general. How to differentiate 8x? So let's say in general, if I have kx, you have to think of this as kx power 1. And then when you differentiate, what happens is, first step, power 1, bring in front and multiply. 1 times k is still k. So it's still k. Second step, the power, you minus 1. 1 minus 1, 0. And we have to know that kx, x to the power of 0 is 1. So we have to know that x to the power of 0 is equal to 1. So because of that, k is the final answer. Okay, so I put it in general form so that you will feel like this is a formula. Okay, a formula. So I put it in this form. If you have y equal to kx, dy dx equal to k. For example, if you have y equal to 3x, dy dx equal to 3. If you have y equal to half x, dy dx equal to half. Okay, so now when we have this, when dy dx, when you differentiate ax, then you get 8. You get 8. If you want to do this process, just go ahead. Power 1 multiply with k, then 1 minus 1 becomes 0. If you want to do step by step, it's okay. Or if you want to do straight away, that will be better. So differentiation of ax is 8. Okay, so this is only true for x power 1. Remember that, for x power 1. Okay, now we look at another example. Y equal to 5 square root x. So we know that square root x is x to the power of half. Then we do dy dx. So you know, based on the formula, the power, the first step is the power half have to come in front and multiply. 5 multiplied with half is 5 over 2. 5 over 2. Second step, minus 1 to the power. Minus 1, half minus 1 is negative half. Okay, and normally we don't leave the answer like this because the question is in square root form or surd form. So we normally change it back to surd form as well. Okay, so what we understand is when we have a negative power, it goes to the denominator and it becomes positive power, positive half. Then the thing is, x to the power of half is square root of x. So because of that, we can put this as the final answer. Okay, so we have 4 examples, which is based on formula number 1. Formula number 1. Okay, so maybe I can give you one more. Some students, they are a bit confusing with something like this. If I have y equal to 3 over 4x cubed. So 3 over 4x cubed. This is a little bit related to example in B. So where I say if the x stay at the bottom, you have to bring it up. Now the x stay at the bottom again, so I have to bring it up. The thing is, when you bring up the x cubed, right, don't move the 4. The 4 remain there. 3 over 4. Only the x cubed go up and become x to the power of negative 3. So that is the thing. Some students, they misunderstand. They bring up the 4 and the x cubed together. But actually the 4, no need to care about it. Just leave it there. Just leave it at the bottom. Just bring up the x cubed and become x to the power of minus 3. Okay, so you know, if you want to bring up the 4, right, so it will become something which is a bit confusing. 4 to the power of negative 1, x to the power of negative 3. So no point to bring up the 4 to make it taking negative 1. Okay, so we just leave it at the bottom. That will be good enough. And dy dx. So where the second step is, the first step of doing this is we take the power minus 3 multiply with 3 over 4. Minus 3 multiply with 3 over 4, we get negative 9 over 4. Second step, minus 1 to the power, and we get minus 4. And since the x take negative power, we can bring it down to the bottom. And now it takes power of positive 4. And we leave it as the final answer. Okay, then, yeah.
How do you do the straightforward method again?
Straightforward method that you mean, is it?
The C one.
C. Okay, let's look at C again. Straightforward method for C. Okay, So you mean this one? Kx become k?
Yeah.
So kx become k, ax become a. So it's like kx, we don't want the x, become k. Ax, we don't want the x, it become a. This is only true for
Okay.
power 1. Yeah, x power 1. Yeah, so when you have these things, right, I think of another example. Okay, so which is this situation, written in number 2. So you try to look at this. Special case, when n equal to 0. That means imagine we have ax to the power of 0. Ax to the power of 0. X to the power of 0 is basically 1. So if you have y equal to ax to the power of 0, right? So basically the question is y equal to a. The question is y equal to a. X power 0 is 1. So that's why the x is not there. Only a. So the question is y equal to a. So which means your question is a constant. Then the dy dx is equal to 0. Dy dx is equal to 0. So let's say example. Okay. Y equal to 3. Then dy dx equal to 0. Okay, based on number 2. So if you want to do step by step, then it is going to be like this. Step by step. If you have y equal to 3, that means y equal to 3x to the power of 0. Then to do differentiation, first step, power 0 shift in front. 0 times 3 is 0. And then x supposed to be 0 minus 1, right? But no point also, because 0 multiplied with x to the power of whatever, it will end up with 0. So this is step by step. Okay, so you can see something like this. You can see something like, in general, I put together, if y equal to k, dy dx equal to 0. So I can just gather up the situation in this way. If you have power 0, y equal to k, dy dx equal to 0. If you have power 1, I mean x power 1, so y equal to kx, dy dx equal to k. If you have power 2, y equal to kx squared, dy dx equal to 2kx power 1. So you will see that power 0 is a bit special. Power 1 is also a bit special. Power 2 onwards, like normal already, where you can apply the step that I mentioned just now. The 2 bring in front, multiply, and then the power you minus 1. So power 2 onwards, it looks normal. Let's say power 3. Power 3, y equal to kx cubed. Normal also. Dy dx equal to 3kx squared. So power 3 bring in front and multiply. Power 3 bring in front, multiply, and then power 3 you minus 1 become 2. So it looks normal already. Okay, so from here we understand that there are only 2 special case, which is power 0 is a special case. A number differentiate becomes 0. No matter what number is that, like y equal to 1 over 2 divided by x, 0. Y equal to negative 1 billion divided by x equal to 0. So as long as it is a number, then it becomes 0. So as long as x is not there, it will become 0. So if x is power 1, then straight away become the coefficient. So like 3x become 3, 8x become 8, half x become half, negative 3x become negative 3, or even fraction, 1 over 2x become 1 over 2, even decimal coefficient like 0.1x becomes 0.1. So power 2 onwards is normal already. So this one I assume you know. Okay, so let's see more example. Okay, number 3 then. Number 3, if you have y equal to an x term plus another x term, then the differentiation is you differentiate the first x term, then plus with the differentiation of the second x term. That means you differentiate term by term. So let's say example. I put at the side of this. You can refer to this at the same time. If I have y equal to 4x cubed minus 3x squared plus 5x minus 7. Okay, so we have one x term, the second x term, the third x term, the fourth constant term. So we have 4 terms over here. The idea is differentiate term by term. Okay, so dy dx, term by term. Okay, so for example, 4x cubed. You know this idea, right? So power 3, put it in front and multiply. 3 times 4, 12. Minus 1 to the power, you get 2. Okay, the second term, power 2, right? So normal step, right? Power bring in front, then multiply, and then the power decreases by 1 unit. Okay, power 2 bring in front, multiply with negative 3, you get negative 6. 2 times negative 3 is negative 6. Then x to the power of 2 become x to the power of 1. Next one, the third term, 5x. So 5x, special case. 5x become 5. Okay. And then negative 7, special case. Negative 7 is constant term. dy dx, 0. Okay, so negative 7 you differentiate becomes 0. If 0, then no need to write. No point to write minus 0 or plus 0. No point. So it's just no difference. Okay, so the final answer is like this. So the idea is differentiate term by term. Okay, so this is the first page. So we have done everything here. And then, okay, we move on. Okay, let's see more example. We look at B. Find the first derivative of each of the following functions. Okay, so you can see one term add with another term. Okay, so we have to differentiate term by term. dy dx equal to, okay, so imagine the power 2 bring in front and multiply. 2 multiplied with 4 is 8. Then the power 2 you minus 1 become power 1. So it become 8x power 1. I just write 8x. So 3x is the special case just now. 3x become 3. Okay, now B. Yeah, one term here, another term here. Okay, so if they give us fx, after doing differentiation, we write f prime of x. F prime of x. Okay, so 7x, the special case just now, if you still remember the power 1, kx become k. So 7x becomes 7. Special case. Minus 3x squared. So this one you just do like usual. Power 2 bring in front. Multiply. 2 multiply with negative 3 is negative 6. X. Power 2 you minus 1 become power 1. Power 1. 6x power 1. Negative 6x power 1. Okay, and then C. So if you still remember, C is the third form. You know, this is the first form. A show us the first form, y become dy dx. B show us the second form, fx after differentiation become f prime x. C is the third form. Differentiate 6x minus 4. You just write the answer straight away at the bottom. Equal to, straight away equal to, we don't have dy dx on the left, we don't have f prime of x on the left. You can straight away write equal to something. Okay, equal to what? Okay, so power 1, 6x. You know, this is the special case. 6x, like just now, kx, differentiation become k. So 6x, you differentiate, become 6. And then minus 4. If you still remember, minus 4 is the power 0 that I put just now. Power 0, constant term. Y equal to k, dy dx equal to 0. If you still remember that. So this is the constant. Minus 4 is the constant. You do differentiation, it becomes 0. So it should be 6 plus 0, you know, or 6 minus 0. So at the end, I just write 6. So a constant will become 0. Okay, then let's move on. Okay. Let's say one special example here. We look at this. If one term is not staying at the bottom, but another term is staying at the bottom, so how to write? Okay, how to present the answer? So when you have something like this is getting ready for differentiation, but this one is not getting ready because you need to bring it up first. So you have to write back the whole thing, d over dx, x squared minus x minus 2. I bring up the x squared to make it to become x to the power of negative 2 so that I can use the formula afterwards. So because of that, I'm not starting my differentiation yet, and that's why this d over dx we have to write back. So when both terms are getting ready, now I can start doing differentiation. X squared become 2x. Then for this 2x because the power 2 bring in front, so that's why 2. Then second step, the 2 you minus 1 become 1. That is the first term, y2x. The second term, minus 2 you bring in front and multiply with the negative 1 here. This is actually negative 1. Minus 2 times negative 1 is positive 2. Positive 2x. Okay, negative 2 you minus 1 again, become negative 3. So 2x plus 2 over x cubed. So we get something like this. So it's a bit special, so that's why I try to let you see how we show the working. Okay, how we show the working. Okay. Now let's look at C also. Okay, look at C. Find the value of the first derivative and the given value of x for each functions below. Okay, so they give us y equal to something, and then they give us x equal to 1. So what we need to do is, we need to find dy dx. Okay, so I assume you are already familiar with the differentiation. I do it straight away. Term by term. 3x cubed, power 3 bring in front, 6x squared. Okay, and then minus 5x squared, the power 2 bring in front and multiply, minus 10 x power 1. So that is the dy dx. Now they give us x equal to 1, right? So we do it like this. Substitute the 1 into x. Then we count it. 6 minus 10 is negative 4. So we get a value. dy dx is negative 4. Okay, so you see another example. In B, they give fx, so we write f prime of x. Okay, so the first term is 4 followed by negative 7x followed by negative x squared. So the first term 4 is the special case. It's power 0. 4 differentiate, it becomes 0. So I'm not going to write 0. And then negative 7x differentiate. This is also the special case. The power 1 just now. Negative 7x differentiate, negative 7. Negative 7. X squared become 2x. So I get this. Then they say x equal to 3, right? So you can put 3 like this also. You can put 3 here. And then you put 3 here as well. Then you count, you get negative 13. So like that. And